as a common semiconductor device. In addition to amplifying AC signals, triode can also be used as an electronic switch. The switching characteristics of triode is widely used in automotive circuits, such as transistor voltage regulators, electronic flashers, and other circuits. In this class, we will introduce the basic circuit of a triode as an electronic switch. First, we need to know the difference between a triode and ordinary mechanical switches. Compared with ordinary mechanical switches, electronic switches composed of triodes has the advantages of small size, no mechanical contacts, switching speed, and easy to control by electrical signals. It is widely used in electronic circuits. When the triode is saturated, it is equivalent to a closed switch. When the triode is cut off, it is equivalent to switch off. Strictly speaking, the triode and the general mechanical contact switch are not exactly the same. In action, it is equivalent to a contactless switch. Next, we take the Balin Wulin triode in the figure. To give a specific explanation, the Balin Wulin triode is a common NPN transistor. Here it acts as an electronic switch triode. How to control the on-off of the light bulb? In fact, as long as the base input voltage is high level, assuming that the high level is 5 volts and 9 volts for low level, the triode obtains a bias current and conducts. Resistance between the collector C and emitter E of the triode becomes very small. It's like a closed switch. Then the light bulb is powered on and lit. When the base input voltage is low level, the emitter junction of the transistor is reverse biased, and it is in the cutoff state. The resistance between the collector C and emitter E of the triode becomes very large. Like a switch that is open, the light bulb goes out. The resistor R in the figure is the base current limiting resistor of the transistor. Prevent excessive base current from the front stage, drive circuit to the triode and damaging the triode. When the emitter junction of the triode is reverse biased and the collector junction is reverse biased, the triode enters the cut-off state. This is like a faucet that is not turned on. The water inside the tap will not flow out, as shown in the figure. In the cut-off state, the collector and emitter are not conducting, which is equivalent to a switch being turned off. At this time, the current of each electrode is almost zero. When the emitter junction of the triode is forward biased, the triode operates in saturation state. In saturation state, the collector current IC of the triode is no longer controlled by the base current IB. IC is no longer proportional to IB. This is equivalent to the switch of the tap is already turned on quite large. When the switch is opened further, the water flow will not increase anymore. In saturation state, the voltage drop between collector and emitter UC is small. If it is a silicon triode, the voltage between collector and emitter use is about 10 R's, which is equivalent to the switch being closed. In summary, we know that when a triode is used as a contactless electronic switch, it works in saturation and cut-off regions alternately. In saturation region, it is the switch on, and in the cut-off region, it is the sweetest disconnection. The condition for saturation is that both emitter and collector junctions are forward biased. The cut-off condition is line or reverse bias of emitter junction, and the collector junction is reverse biased. How to use a triode to control the on-off of indicator? Let's take these two figures as examples. The left figure is an NPN triode. When the positive input is a high potential control signal, the triode will conduct and enter saturation state. The collector circuit current is large, and the voltage between collector and emitter is close to zero. At this time, the triode is equivalent to an on switch, and the indicator light is lit. When the base goes from high potential to low potential, the triode is cut off. It is equivalent to a switch-off switch cutting off the collector circuit. The indicator light goes out. The right figure is the end transistor. When the positive input is a low potential control signal, the triode will conduct and enter saturation state. The collector circuit current is large, and the voltage between collector and emitter is close to zero. At this time, the triode is equivalent to an on switch. The indicator light is lit. When the base goes from low potential to high potential, the transistor is cut off. It is equivalent to a disconnected switch cutting off the collector circuit. The indicator light goes out. From this example, we can see that whether it is an NPN transistor or in triode, as long as the collector input corresponding control signal, the triode can be saturated or cut off. It can act as a switch. By learning the application of triode switching circuits, we know that the triode used as an electronic switch mainly alternate between saturation and cut-off regions. The condition for the triode to be saturated is the collector junction is forward biased. The condition for the triode to be cut off is the emitter junction is zero biased or reverse biased, and the collector junction is reverse biased. A small switching circuit has such wonderful and practical functions. I hope you can continue to explore in the electronic world and feel the charm of electronics. After class, please think about how does the car transistor voltage regulator work.